The cockpit was barely wide enough to breathe, metal pressed in from all sides. Gouges trembled as the aircraft separated from its carrier plane, the Pacific Ocean spreading endlessly below. This was not a fighter. This was not a bomber. It was a weapon with a human heartbeat inside it. The Yokosuka MXY-7 Oka, ironically named after the cherry blossom, a symbol of fleeting beauty in Japanese culture, was a manned missile designed for a single purpose: impact. Once released, there would be no landing gear, no return flight, no second decision, only acceleration, guidance, and collision. To Allied sailors, it earned a darker name, the Baka bomb. But dismissing it as crude misses the deeper truth. The Oka was not born from ignorance. It was born from desperation. By the final phase of the Pacific War, Japan faced overwhelming American naval power, shrinking resources, and a strategic horizon closing fast. So a radical question emerged inside Japan's military leadership. If technology and industry could no longer match the enemy, could sacrifice, close the gap, the Oka was the answer they chose. What kind of war produces a weapon that demands absolute commitment from the moment its engines ignite? And what does that decision reveal not just about Japan in 1945, but about the limits of technology, strategy, and human endurance in modern warfare? By the final year of the Pacific War, the strategic balance had shifted beyond recovery for Imperial Japan. The skies belonged to American carrier aircraft. The seas were dominated by fast-moving task forces protected by layered anti-aircraft fire and radar-guided coordination. Each month, Japan's industrial capacity shrank further under sustained bombing, while trained pilots and experienced crews became increasingly irreplaceable. It was within this narrowing margin of survival that the logic of desperation took hold. Japanese naval planners understood a grim reality. Conventional aircraft could no longer reliably penetrate American fleet defenses. Even experienced pilots struggled to reach their targets before being intercepted. Fuel shortages limited training. Replacement aircraft rolled off assembly lines faster than men could be trained to fly them effectively. Strategy, as it had once existed, was collapsing under material reality. Out of this crisis emerged the concept of special attack weapon systems designed not for endurance, but for certainty. The kamikaze doctrine was not initially envisioned as a romantic gesture or spiritual ideal. It was a calculated response to strategic imbalance, an attempt to convert human resolve into a substitute for industrial power. The Yokosuka MXY-7 Oka was conceived within this mindset. Rather than asking a pilot to fight through American defenses, the Oka assumed those defenses were impenetrable. The solution was brutally simple. Shorten the engagement window to seconds. Carried beneath a Mitsubishi G4M Betty bomber, the Oka would be released at range. From that moment on, speed not maneuver would be its protection. Once its rocket engines ignited, interception would be nearly impossible. This was not a weapon meant to turn the tide of the war. Japanese planners knew that. It was meant to inflict localized, disproportionate damage to break ships, disrupt formations, and force the U.S. Navy to treat every approaching bomber as a potential catastrophe. The Oka was designed to exploit a single vulnerability: reaction time. Its development reflected a shift in priorities. Survivability no longer mattered. Reusability was irrelevant. Every design decision was made under a single assumption that the aircraft would not return. In that sense, the Oka was not merely a weapon system, but a manifestation of a collapsing strategic environment where sacrifice became embedded into engineering. For the young pilots selected to fly it, training emphasized precision rather than tactics. There would be no dogfights, no evasive maneuvers, no alternate objectives. Their role was reduced to guidance, timing, and final alignment. The war had reached a point where victory was no longer the goal. Inflicting cost was. And from that calculation, the Oka entered the conflict not as an experiment, but as an admission that Japan was fighting the last phase of a war it could no longer win. The Yokosuka MXY-7 Oka was not designed like a conventional aircraft. It was engineered with a single assumption embedded into every rivet and panel. This machine would fly only once. Its fuselage was long, narrow, and brutally efficient, just under 20 feet in length, barely 2 feet in diameter. Inside, an aluminum airframe ran the length of the body, supported by longerons and formers that gave the structure strength without excess weight. Aluminum skin was fastened directly over the frame, not for durability but for necessity. Every ounce saved was an ounce redirected towards speed. That philosophy became even clearer at the nose. Most of the Oka's forward section was consumed by its warhead. Encased in steel, It was designed to pierce the armored decks of American warships before detonating. The warhead alone weighed more than 2,600 pounds, over half the total mass of the aircraft. More than 1,000 pounds of that weight was explosive. This was not an aircraft carrying a bomb. It was a bomb given wings and guidance. Behind it, the wings stretched just under 17 feet from tip to tip. Aluminum spars and ribs formed the internal structure, while balsa wood was used for the outer skin. It was a fragile solution by peacetime standards, but adequate for a weapon that would never face long-term stress. The ailerons provided roll control, but maneuverability was not the goal. Stability was. That requirement shaped the tail design. The Oka featured two horizontal stabilizers, a twin-tail configuration that served a critical purpose. With such a massive warhead in the nose, balance was a constant concern. The twin-tail acted as a counterweight, providing control and stability at extreme speeds during the final dive. It was an elegant answer to a grim problem: how to keep a missile steady long enough for a human to aim it. Nothing about the Oka suggested improvisation. Despite its simplicity, it was a carefully calculated system. There was no landing gear, no flaps for recovery, no consideration for pilot survival. The aircraft did not need them. It needed only to remain controllable until the last few seconds of flight. This was the peak of Japan's special attack philosophy, not emotional symbolism, but cold engineering logic. The Oka represented a fusion of aeronautical design and strategic desperation, where human life was treated as a guidance component rather than an asset to be preserved. In the final seconds of an attack, when the aircraft would be accelerating beyond the reach of defensive fire, the Oka's design fulfilled its purpose. Not by endurance, not by adaptability, but by certainty. And once that certainty was achieved, nothing else mattered. At the rear of the Yokosuka MXY-7 Oka was the element that transformed it from a guided bomb into something far more dangerous: its rocket engines. 3 Type 4 Mark I model, 20 solid-fuel rocket motors were mounted in the tail. Unlike piston engines or jet turbines, these rockets were brutally simple. Once ignited, they could not be throttled, they could not be shut down. They burned until exhaustion. In the logic of the Oka, this was not a flaw, it was a feature. Solid rocket engines function by burning a pre-mixed propellant that contains both fuel and oxidizer. When ignited, the chemical reaction produces extremely hot, high-pressure gases. These gases are expelled through a nozzle at the rear, generating thrust with explosive efficiency. There was no complexity to manage, no prolonged operation to sustain, only acceleration. According to post-war analysis conducted by American scientists, the Oka's propellant was a volatile mixture dominated by nitrocellulose and nitroglycerin, stabilized with chemical additives. The result was a short but violent burn, producing nearly 600 pounds of thrust. For a small aircraft already diving toward its target, that thrust translated into devastating speed. Inside each engine were 6 tubes of solid propellant, arranged in paired groups. When activated, an igniter at the forward end of the motor sent burning particles and hot gases down the cores of the propellant tubes. Ideally, ignition occurred evenly along their length, ensuring symmetrical thrust. If it did not, the consequences could be catastrophic, and the responsibility for triggering that process rested entirely with the pilot. At the chosen moment, usually after release from the carrier aircraft and alignment with the target, the pilot would activate the ignition system electrically. There was no dramatic countdown, no warning, just a sudden surge of force as the Oka leapt forward, compressing the pilot into his seat. From that instant onward, the engagement was irreversible. Speed climbed rapidly, pushing the aircraft beyond the practical limits of shipboard anti-aircraft fire. Defensive gunners had only seconds to react. The Oka's trajectory became steep and direct, its guidance corrections shrinking as velocity increased. There was no room for hesitation. Every control input had to be precise. This was the point where engineering and human fate collided. The engines did not care about doubt or fear. They burned according to chemistry alone. The aircraft structure, light and unforgiving, transmitted every vibration directly to the cockpit. The pilot had no illusion of survival. His role was reduced to alignment to ensure that the kinetic energy of the machine would be delivered exactly where it would do the most damage. When the rockets finally burned out, there was no deceleration, only momentum. What followed was not a maneuver or a tactic, but an outcome already decided the moment the ignition circuit closed. The Oka did not fail or succeed in the conventional sense. It either reached its target or it did not. And in that final dive, the line between weapon and operator vanished entirely. The cockpit of the Yokosuka MXY-7 Oka was not designed to be endured. It was designed to be occupied briefly, intensely, and for the last time. There was no room for excess. The pilot sat enclosed by thin metal panels, surrounded by instruments that offered information but no escape. Directly in front of him were the controls that mattered most. A red arming switch activated 4 of the 5 fuses embedded in the massive warhead ahead. Once thrown, that decision could not be undone. The aircraft had not yet struck its target, but the outcome was already committed. Another switch allowed the pilot to select which rocket motor would ignite. 1 engine, 2, or all 3. This choice was not about survival, but timing. Too early, and the aircraft might overshoot. Too late, and defensive fire could still reach it. The Oka demanded judgment even as it removed all possibility of retreat. The remaining instruments reflected a strange contradiction. A compass pointed north with quiet indifference. An altimeter measured height above sea level, even though there was no landing field waiting below. The airspeed indicator, fed by a pitot tube on the wing, climbed rapidly once the rockets ignited, its needle swinging into ranges where small errors became fatal. A turn-and-slip indicator, driven by a gyroscope, helped the pilot understand his orientation in the horizontal plane. It was a tool meant to prevent disorientation, yet it could not prevent the ultimate collision. The aircraft still required control, precision, and calm, even as its purpose denied the value of those skills beyond a few final seconds. There was also a simple intercommunication system, capable of transmitting Morse code back to the carrier bomber. It allowed brief signals, confirmation, readiness, perhaps a final acknowledgement. No record remains of what was said in those moments, but the existence of the system alone suggests that silence was not always acceptable. Inside that cockpit, the pilot was neither passenger nor hero. He was a component essential, irreplaceable, and expended by design. The Oka did not rely on blind courage. It relied on trained restraint, on a steady hand guiding an unstoppable machine toward its conclusion. This was not chaos. It was controlled finality. And within that narrow space, surrounded by dials and switches, the human cost of desperation became impossible to ignore. From the perspective of the United States Navy, the appearance of the Yokosuka MXY-7 Oka introduced a new and unsettling variable into an already lethal battle space. American forces had grown accustomed to defending against conventional aircraft, even kamikaze attacks. But the Oka altered the equation by compressing time itself. Once released, its speed left gunners with only seconds to react. U.S. naval intelligence quickly recognized that the Oka was not intended to be launched independently. Its true vulnerability lay in the aircraft that carried it. Mitsubishi G4M Betty bombers, already fragile and poorly protected, became high-priority targets. American fighter patrols adapted accordingly, pushing interception lines farther out, destroying the carrier aircraft before the Oka could ever be deployed. In this sense, the Oka forced tactical adaptation, but it did not force strategic change. After the war, American engineers and scientists examined captured Oka units with clinical detachment. Their assessments were precise and unsentimental. The propulsion system was effective. The warhead was formidable. The guidance concept, placing a human operator inside a high-speed terminal weapon, was undeniably accurate. But accuracy alone was not enough to overcome systemic weakness. From a strategic standpoint, the Oka represented a fundamental imbalance. It converted trained pilots into single-use components, while the United States leveraged mass production, layered defense, and replaceable hardware. One system consumed human capital irreversibly. The other preserved it. This contrast shaped post-war military thinking. American doctrine would move in the opposite direction toward unmanned weapons, standoff munitions, and technologies that removed pilots from terminal risk whenever possible. The Oka, while extreme, underscored a lesson that would define modern warfare. Effectiveness is measured not just by destruction inflicted, but by sustainability over time. Globally, the Oka became a symbol, rather than a blueprint. Other nations studied it, but few sought to replicate its philosophy. The moral and practical costs were too high. Precision-guided weapons would evolve rapidly in the decades that followed, but they would do so without embedding a human life at the point of impact. In the end, the Oka did not terrify the world because it was powerful. It unsettled observers because it revealed how far a nation might go when conventional options collapse. It was a warning, not of technological possibility, but of strategic desperation. And that warning would echo long after the Pacific War had ended.